Yes, sir. Please, sir.
Yeah,
So we'll move on with the Osce session, sir, about the Anesthesia workstation.
Are you able to see the screen?
Yes, sir.
Yes, sir.
Okay. So it is about the anesthesia machine. The entire Osce is on anesthesia machine and equipment. It is not on anything else. So we start with this. Now I am showing pictures of few machines here. Okay. Can you tell what is the difference in these machines?
First one is old boils and last is advanced workstation.
Yeah, this is the latest workstation. This is a very old coils machine with no circle absorber, only 2 flow meters, one for oxygen and one for nitrous oxide. What type of vaporizer is this?
Halogen.
Ether, sir.
Ether.
What is the name for that? In those days it is used for halogen, but what is the name of this vaporizer? Called the Goldman vaporizer.
Goldman.
Goldman, Goldman, Goldman. And what is this vaporizer called? Are you able to see my pointer showing the vaporizer?
Yes, sir.
Sir,
Yes, sir.
What is this vaporizer called? This can be called as a boil bottle. Okay, boil bottle. This is actually used. This is a little cylindrical and longer bottle. This was used for a volatile anesthetic agent called trilene. So in the other machines, you may have another vaporizer for ether first and then trilene second. Okay, so that ether bottle also is called boil bottle. These are called very basic vaporizers with no temperature compensation, no output concentration, nothing is precise. It will deliver. The control is there in the lever here. Okay, so these are the things. But later on, they have improved slowly with the multiple pressure gauges and the modern tech vaporizers, the ventilators, and all these things are there. And this is the normal anesthesia machine. And so workstation requires, what does it require apart from
electrical component.
this is a major difference here. They are both electrical as well as
Pneumatic.
pneumatically operated.
It
Whereas the
attached
older
with
machines, they are
monitors.
only operated by pneumatic power. So no electricity is required. So even in power failure, these machines can work. Whereas the modern machines can work only for a few hours with the battery backup. So power failure will affect the working level of these machines. Okay. Much is not moving much. This can this be removed?
Yes, the screen is what is shown in this picture.
Yeah, now I'm able to close it. Now what is shown in these pictures? Can you identify this?
Cylinder manifold. Cylinder manifold.
Manifold. But anything else you have to say add to this answer?
Oxygen cylinder.
How many
Central
banks are
supply.
there? How many banks of cylinders are there?
4, 8.
These are 2 banks, manifold with 2 banks. This is
Two
bank
banks.
A and bank B. Okay, so always they will have multiple cylinders. Depending upon the requirement, you can have many number of cylinders attached. But always one will be a standby and another will be in use. So there is a regulator here which will decide once the cylinders in use are emptied out, the other one will automatically open. Once the pressure drops here, automatically. So you have to keep all the cylinders open position. So you should not keep the reserve cylinders in closed position. So automatically they will start feeding without disruption or interruption in the supply. What is this? This is the correct method of storing the cylinders. And what is this? This is a method of transporting cylinders. But most of the time, the theatre assistants will just carry it in the shoulder and bring it. But that should not be the way. This is the correct method of transporting the cylinder. Now, what is this shown here?
Liquid oxygen.
Liquid oxygen tank, which is produced. Very good. And what is this?
Filling of liquid oxygen.
Filling of the liquid oxygen. Very good. That is what is VAE? What is the expression?
Vacuum insulated.
Vacuum insulated
Evaporator.
evaporator. Correct. What gases can be stored in them and for what purpose? Is it only for oxygen or you can use some other gases also for the vacuum insulated evaporator? So it can not only store oxygen, it can store nitrogen, argon for industrial purpose as well as medical applications. Okay, so don't think that this liquid oxygen plant is the liquid plant is only for oxygen. It can be for nitrogen and argon also. What are the technical considerations for hospitals to set up the vacuum insulated evaporator systems?
It
Supposing
should
you
be
can
away from the building distance.
capable of storing liquid oxygen, which is cryogenic in nature and approximately minus 183 degrees centigrade. Okay, that is the temperature. And standard operating procedures for pressures of bulk tanks. The pressure is 16 bar, and it can be as high as 35 bars also. And liquid oxygen tanks are very heavy and require specially designed reinforced concrete slabs to bear the loading. Okay, and source of ignition, so prohibited with the any lighting or lights or the smoking, everything should be avoided in the storage location. And as you said, it should be in a well ventilated, least transpassed area. Patient or attendant should not go near that area. So it should be in an isolated place. And it should have a proper approach so that the filling can be done, because the entire truck has to come to fill. So it should have a good approach road, and then connection also should be there. Again, what is shown in these pictures? What are all these things?
Wall mount.
Wall mounted.
Diameter.
Color coded
Outlet.
self-sealing valves. Okay, so this is called the self-sealing or Strader valve, and these are all the color coded ones. Oxygen, nitrous oxide. Gray is for, what are these two? Sometimes, instead of yellow, it can be for suction, and another one for the
Air.
So all the names will be written there. What is this picture showing?
Hose connection connected to the wall mount.
Again, color coded high pressure hoses with diameters. This portion is called the probe. This is the
Diameter
probe you
specific
have
probe.
to insert into this. Okay, so it's the color coded high pressure hoses with diameter specific. The next diameter here will be different. That is why you cannot insert this into medical air, cannot be inserted into nitrous oxide, or nitrous oxide cannot be inserted into oxygen, because the neck diameter is different. So that is how the connection of wrong hoses is prevented. What is tug test?
To pull after connection, you pull the hose.
Pull it, so see whether it is firmly and tightly connected, otherwise it will slip and come off. So you always do the tug test. And this is the close-up view of this probe. which you see. This is the portion which goes inside, and this is the portion where the hose will be fitted. Okay, this portion, and you find a metal here to tighten this hose here. What is that metal called? All of them have this metal. These two have the metal circling these hoses. That is called the ferrule. 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 Okay, so it is a machine compressed so that the hose, because these are all high pressure hoses, they should not slip and come out. So there is a metal protection which is called the ferrule. Ferrule. And this is the, what is this? Here you saw this is a wall mounted. So where is
Ceiling
this
mounted.
is mounted?
Ceiling mounted.
Ceiling mounted. Yes, ceiling gas outlets with color coded hoses again. Now what is this?
Sir, for the cylinders diameter
this
index,
this is the
pin index safety system.
pin index valve with the this delivery block. Okay, pin index for oxygen nitrous oxide, which will be attached to the machine. Okay, so this is the pipeline delivery outlet, and then the whole thing goes into this portion, goes to the machine where it will be fitted to the, which portion of the machine will hold this? What is that portion called? The anesthesia machine, where you insert this block and then fit it so that the gas comes through. This is the hole for the gas to come out. Where will you fix this? Which part of the anesthesia machine this is fitted? It's called the hanger yoke assembly. Okay, it's called the hanger yoke assembly. You will see the picture here soon. So this is another method of oxygen hose attached to the back of the machine. And what is this?
The pendants for the
This
electrical
is called the
connections.
ceiling pendant, from where you can
Pendant.
take the gas outlet. So here it is directly fixed to the ceiling here. So reaching it may be difficult. So in order to make it easy for you to connect the hoses here, they put a pendant here so that you can easily insert, and it can have multiple uses. You can have the power outlets on one side, you can have the gas outlets on one side, you can have the working desk. All these things can be done, so more space will be available. And this is another method of showing the wall outlet newer designs. So this is an older design where you use the self-sealing or shader valve. This is the newer design where wall outlets for pipeline gases. So from the central pipeline, this is where you just insert and then take it out. This is also another model of the self-sealing valve. Here you have to push the probe inside and twist it, whereas here you can just insert easily. So this is a newer design of wall outlet. Now what is shown here?
A stuck test, sir.
Cylinder.
B is looks like removing the oxygen hose from the
From the
inlet
outlet. That is rather
outlet.
this
outlet.
is
C is
pendant,
where
you know,
the cylinder is hanged in the machine.
this is
Hanger
the
and-
machine. This portion is called the hammer yoke assembly.
Hanger yoke.
The hanger yoke assembly, where this is the portion which is going to hold the either the pipeline insert or the cylinder can be held in that. Of course, they will be asking you about the parts of that, which you will see in the. So tracing the gas supply from wall outlet to the machine. So from either this wall outlet or this wall outlet, ultimately it has to come to the hanger yoke assembly or the modern connections in the later machines. I will show you the pictures. So what are you seeing here?
Mounted cylinders on the back of
Hanger yoke assembly with oxygen and nitrous oxide
Nitrous oxide.
cylinder. Okay, cylinders. So both the cylinders are attached here. Because now you are all quite familiar with the workstations, you don't have the opportunity to see how these are fixed. Normally, these cylinders are kept at the back in the workstations. So Majority of the times you don't see how they are removed and fixed. So the opportunity is not may not be that frequent. And you can see there is a hanger yoke assembly which is not having any cylinder here.
Empty.
So this is the empty hanger yoke. This is the one. What gas is fixed here?
Nitrous
Nitrous.
oxide.
Nitrous oxide. By the color coding, you can identify it. This is the oxygen cylinder.
Oxygen.
which is
Oxygen
there.
cylinder.
Okay. And what is this? This is the
The pipeline system on the
Pipeline
back
to
of
disconnection.
DAS
pipeline.
connection. This is called the diameter index
Index
connection for newer machines. Okay. So instead of having the older type, this is the newer method of connection. What are these things?
pressure indicators.
Pressure gauges for oxygen, nitrous oxide, and medical air. What is this?
Common
pressure and below is cylinder pressures.
The above is showing the
read
full
from here.
cylinders.
So both the pressure gauges for not only the pipeline as well as the cylinder fixed
Cylinder
in
pressure.
Cylinder pressure.
So older machines have only the pipeline pressure indicators. So if you do not know whether the cylinders filled in the machine are full or not. So they have now incorporated the pressures in the cylinder. You can open the cylinder, read the pressure and then close it so that you can have them for reserve. And pipeline pressure will start dropping if there is a drop in the central supply in the manifold. If the cylinders that exhausted, the pressure will start dropping. At the time, you can immediately open the cylinders and then use the supply continuously. And again, what is shown here? The machine you are using day in and day out. Identify all the parts.
Automatic pressure releasing valve, APL valve, and the pressure indicator.
It's called automatic or adjustable pressure releasing.
Adjustable.
Adjustable
Ah,
pressure.
it is not automatic. It is, you
Sorry,
have to adjust
adjustable.
it by twisting it. Okay, it is
Okay.
called adjustable pressure. APL A stands for adjustable pressure releasing
Pressure
valve.
limiting.
Then what about this? What is this? Which pressure does it read? All of you are using these
Peak
machines
airway
nowadays.
Airway
Airway
pressure.
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 This is the airway pressure gauge. Okay, and what is this?
The
For
switching manual.
adjusting between bag and
Manual and
ventilator.
The lever to switch from bag to ventilator or ventilator to bag. Okay, this is called the lever, not the toggle. It's called the lever to switch from bag to ventilator or ventilator to. So APL valve knob, airway pressure gauge, lever to change from bag to ventilator. What is this?
Board-on pressure gauge, sir.
Pressure
Board-on
gauge.
pressure gauge, sir.
Found on oxygen pressure gauge. Okay, see, whenever the thing is there, you must say the whole thing. Okay, so it is called oxygen pressure gauge and working on Bourdon principle. Okay, so this is the principle under which it is working. I'll show you later slides which will explain this. What is this?
Pressure
Cylinder.
indicator in the cylinder.
Pressure.
So
See, this is
it
a
connects the
attachment for the
high
old
pressure and
machines.
low pressure system.
So there is a one entry port here. Immediately there is a pressure gauge. Then there is another part here, and then there is a third part here. So this is the entry port from either the cylinder or pipeline. Okay, this will be screwed into that back of the hanger yoke assembly in the Boyle's machine or in the anesthesia machine. And then once you open the cylinder, the pressure will be read here, and this will be reduced by the pressure regulator. This is a pressure regulator. And then from here it will go out. This is the outlet going to the flow meter or the oxygen safety valve or alarm, everything. This is the outlet. So high pressure gases come here, then it is reduced here, and this is the outlet going to the flow meter. Okay. So unit of anesthesia machine consisting of gas inlet, pressure gauge, pressure regulator, and downstream outlet. That is downstream means going to the flow meter. What is this?
New machines Same.
Two-stage oxygen pressure
Oxygen pressure
regulator. This is the two-stage oxygen pressure regulator. One for reducing it from very high pressure, that is 2000 psi to say 50 or 60, and then further, if you want to reduce it for pod use, you can reduce it even to 15 to 20 psi. So it is called the two-stage oxygen pressure regulator. Identify what is shown here.
Pin index.
Pin index is there. Everything is pin index, but the whole thing you must say the name. It is shown here. Stem
Yeah.
is shown here. So this is the front and back of valve assembly cylinder block, front and back. Okay, so it's called the valve assembly of cylinder for front and block. It is attached to the top of the cylinder. This you can this picture if you see, this is the neck of the cylinder, this is the shoulder of the cylinder. So it is screwed into the neck of the cylinder, the manufacturing place tightly so that there is no leak here. And this is the main stem which you rotate to open this, and this is the output port for gas to come out. This is the pin index holes where the pin has to go in to fix that. This is the back side of that where you have the pressure relief device. In case suddenly high pressure comes, this will jump out, or it will get pushed out, and you will have the gases coming out without causing an explosion. And this conical depression which you see here, there, that is where the hanger yoke assembly screw will be holding it in position. Okay? So these are all the things commonly asked in the examination. So there are things marked here. You can see by the line. You can see this one line here, the same picture, but little more extra lines are there. Can you? So this is the screw portion which will go into the neck of the cylinder. Can you identify all these parts?
Above a stem, sir. Stem of
Name
the
the part.
cylinder.
Already it is here for you. The clue is here. There is
Stem
a
of
stem. What is this portion? This is called the gland nut. Okay, this which is holding the stem in position. Sometimes the stem in this level there may be a leak, so you have to tighten this gland nut. Then only the leak will stop. So when you open the stem, then only gases will flow through this. And this is the gland nut to hold the stem in position. This is the body. What is this? A circle which is marked by a line.
Sealing washer kind of
This
thing.
is the Bodex seal. Very good. Washer or
Bodex seal,
Bodex
yes.
seal. This is the port for gas to escape. And what is this? This is the pin index hole.
Pin index stem.
Okay. So you can see cylinder valve stem is the gland nut. This is the valve block actually it should be, and this is the sealing washer or Bodex seal. This is the port for the gas to come out. These are the pin index holes. Okay. What is
Board
this?
spread.
This is the Bodex seal.
Sealing board.
So what are the parts of this Bodex seal? What is this? What is this white circular thing?
So one is a washer, sir.
Yeah, but what ask me, tell me what I am asking.
Wood
This is the
spread.
aluminum ring, okay?
Aluminum
And
ring.
what is this washer material made up of?
Rubber.
Neoprene.
Neoprene rubber.
Neoprene. Okay, it's a neoprene. It's not rubber or it is not plastic. It's neoprene, which is held in this aluminum. Okay, so this aluminum ring has got a groove in which this washer, this neoprene disc will be inserted, and there is a central hole for the port. Okay, so that is the manufacturing component of the Bodex seal. They ask you in the examination. So aluminum ring to hold the neoprene washer in the middle. Okay, that is how the Bodex seal is formed. What are these things?
That's
Pan is for cylinder.
Opening.
Various types of spanners or
Keys.
keys. They are called keys to open the compressed gas cylinders. Okay, various types of keys for opening. And in the most of the older type of machines, if they have that in the exam, the hospital where you go for your exam, they may still have a Boyle's machine in which it be kept for examination. So this particular key will be used in most of them. These two holes will go into the stem to open it. Okay, and this spanner, this will be adequate for tightening the gland nut. If there is a leak in the gland nut, we use this portion to tighten it. Okay, so this spanner has got the multiple use in these two. Why there are two different holes?
Where is with cylinders, oxygen?
If the neighboring cylinder is there, you may have to use the vertical one or the horizontal one, so without hitting on your hand or injuring your hand. So that is the reason. Sometimes the examiner may ask you, especially if the examiner is a older guy, a senior person, they may ask you this. There are two screws, one horizontal, holes, and another vertical to facilitate opening the cylinder without hitting on the neighboring cylinder when it is attached. And this is the gap for tightening the gland nut. What is shown here, and name the parts.
Pressure regulating.
So this is a pressure regulator.
Pressure
Very good.
regulator.
And the parts are, this screw is called the adjustment screw. By tightening or relaxing the screw, you can alter the pressure that is released here. Okay, this is high pressure inlet. This is the regulator outflow. So by tightening or loosening the spring, you can adjust the pressure that you want. There is a spring here. Then there is a diaphragm. This is the one which is using the reduction, and this is a regulated pressure outlet. This is the low pressure area, and this is the high pressure area with a valve seating. Okay, so all the high pressure gases from the cylinder or the pipeline will come here. They will travel through there. Here they will lose their pressure and become decreased pressure will be decided by the position of the diaphragm. So if you keep the diaphragm low, the pressure will be high. If you lift the diaphragm up, the pressure will be low. Okay, that is how the pressure regulator works. Again, this is a very simple thing. Identify what is shown here.
Pin index safety system.
Spin
Pin
index
index for what?
specific for
Of
cylinders.
course, then if I can just show only one picture to say it is pin index, but there are 5 pin indexes. Can you identify for various gases? So this is for oxygen 2,5, this is for nitrous oxide 3,5,
3,5.
this is for
1,5.
air 1,5, and this is for carbon dioxide, and this is for
And
ethanol.
enough.
Ethanol
7.
has got only one. Okay.
Single.
So if this picture is shown, you have to identify all the gases based on the pin index. Okay, not just saying pin index is not sufficient answer. What are the various sizes of cylinders, their capacities, pressures, and tare weight?
Size from A to E,
F, E.
from
Commonly
largest to
used.
smallest.
So this chart will tell you the sizes can be D, D, E, F, G, H, like that. So A sizes are not commonly used now, and their capacity varies like this. The pressure usually is for oxygen 1900 psi and may go up to 2220. What is the tare weight?
Empty cylinder.
Empty cylinder, weight of the empty cylinder is tare weight. Okay, as the size of the cylinder increases, you find the weight also increases. Okay, so tare weight is important. And what is this? Name the parts of this area. This is what we have been talking all along. This is the hanger yoke
Valve
assembly.
assembly.
Hanger.
So this is the hanger yoke of the machine.
Nipple
This
and
is the
pin it.
nipple, and
Pin index.
this is the Bodak seal which will be seated here. And these are the pins for inserting into this cylinder block will have the holes, and the pins are fixed in the machine. So in these blocks, the hole have to be inserted here correctly, and then this is called the retaining screw. So this is the retaining screw. So there will be a lever which will flow over that, and you can tighten that. And that screw only will go onto the back of the conical depression which I showed you in the earlier slide. So this screw goes into that to tighten that. Okay. So these are all the things. With the hanger yoke assembly, please remember that, because you are all used to workstation nowadays. You don't get an opportunity to see this, which is situated in the back side of the machine. And which cylinder is usually fitted in the anesthesia machine among these sizes? Which type of cylinder is commonly fitted?
Indus.
E cylinder. Very good. It is the E cylinder which is mounted on the anesthesia machine. What information is available from the cylinder label? All the cylinders usually come with a label. So what are all the information given in the label?
Content of the cylinder, manufacturing date.
So name of the contents, chemical symbol, physical state, volume, whether it is flammable or non-flammable, service pressure of the cylinder, cylinder size and code, product license number, principal hazards of cylinders and its contents, date of hydraulic testing are all stamped on the cylinder side. Okay, in the shoulder portion it will be stamped. And what is this? These are two types of valves. Okay, so the name is, this is the bull nose and hand wheel valve. The one on this side, this is called the bull nose valve, and this is called the hand wheel valve. So this portion goes into the cylinder, and this is the outlet for the gases to come. So this one is a earlier model where you have to use the key or spanner to open this. So many times you don't find the spanner in an emergency. So to avoid that, they have fixed a hand wheel which can be used to be rotated to open the cylinder. So this is called the bull nose valve and the hand wheel valve. It's shown here. It's a pressure gauge, not pressure indicator.
Pressure gauge.
Which is integrated into the machine itself. Okay, so even a portable cylinder with a pressure gauge integrated into that. What is service pressure of a cylinder? This is a common question in the Osce or in the exam. What is service pressure of the cylinder, of a cylinder? So it's defined as the maximum pressure to which a cylinder may be filled at 70 degree Fahrenheit. Okay, so the maximum pressure with which you can fill the gas inside the cylinder at 70 degree Fahrenheit is called the service pressure. How much more pressure they can withstand? They should withstand more than the service pressure. How much more they should be able to withstand so that no explosion occurs?
3 times the
3 times.
Not 3 times, 1.66 times the service pressure. Okay, slightly more than 1.5 times. Okay, 1.66 times is the of the service pressure is the maximum pressure they should be able to withstand. What is shown here?
Flow meter. Flow meter.
flow meters, low pressure system.
With
Single flow tubes flow meter for different gases.
And
So
gas.
all the it's just saying flow meter will not fetch you mark in the examination. Look at the whole picture, take a little time, and then decide what you have to write. So there is an oxygen, the nitrous oxide. There's a earlier it was carbon dioxide and the cyclopropane, very old machine type, or now air. So these are all only single flow meters for each gases. So single flow tube for flow meter for different gases is the answer for that. And what is this? Again, if you say just flow meter, it is not the correct answer. What should you say? Now that I have told you single flow meter, what do you
Double
say?
flow tube.
Double flow
Twin
meters
flow
for
tube flow
oxygen.
meter. So for each gas, even for air, you have got twin flow meters. Okay, so two tube or twin flow meter. What is the purpose of this twin flow meters? Twin tubes.
Can adjust to low pressure, low flows and high flows.
Low flow and high flow. Very good. So there are the advantage of using low flow anesthesia is very common now. So every gas has got a low flow tube and a high flow tube.
High flow.
So these are called twin flow tube flow meter. What is this?
Digitally
Electronic.
display
digital
flow meters.
Single flow tube with digital
Digital.
display flow meter. Okay, so there's only a flow tube, flow meter tube, which is only 1% here, but it is displaying all the gases in a digital fashion. And what is this? Do you find any glass tubes or any tubes like in the all the earlier three pictures?
No,
No, so
electronic.
it's completely
flow-
digital.
So this is electronic flow
electronic
meter.
flow meter.
Okay, so touch control electronic flow meter, and you can see here oxygen is written, name is written here, and the flow is displayed is 1.5 and nitrous oxide 2, and the air is empty. So everything is displayed here, and it is only a electronic display, no actual tube or float or bobbins are present. But still, what all the things that you are seeing here.
A
Twin
twin
tube
tube flow meter assembly.
Very good. Twin flow tube flow meter for
Okay.
three gases, nitrous oxide, air, and oxygen. Excellent. Then what else you see? There is another flow
color-coded
also here.
Auxiliary single tube.
Another flow meter.
Auxiliary flow tube
Flow.
for oxygen and air. Very
The
good.
air.
Then anything else?
Color coded, sir.
Color coded. Very good. What is this for? Can you see this? Some rod like thing going here.
Yes. sir.
To avoid
what
the
is that?
accidental
So
Movement,
twin flow tubes for flow meter three gases. Protective bar to safeguard accidental knob rotation. That is what is this. Okay, this metal bar is a protective bar. It's called the protective bar for accidental rotation, and auxiliary flow meter for air and oxygen. Okay, so these are all the full three things you must write. Can you name the parts here? Here I have taken the picture or a cut section of a flow
Flow
control
flow meter.
flow meter. This is the flow control knob. Gases flow through this. The float is here. It goes out. So can you name all the parts that are being marked here, which I have hidden? At least one or two. What is this?
Bobbin in the center.
Bobbin in the
Above and
center.
below.
Okay.
Above and below the O-ring.
Always try to start from this. This is the
Ah.
knob. This is the fluted knob.
Fluted
Okay.
knob.
Then there is a pin which is going there. And then it's
Pressure.
going to, this thing will remove. Okay, we'll see the parts here. So flow control knob, it is fluted. Okay, different size of fluting will be there for oxygen and nitrous oxide. Why that different fluting is there? What is the purpose?
Safety mechanism, sir, to prevent hypoxic
Ah.
development.
Touch to
Even if you are no power is there,
Lighting
by
is there,
touching it, you can identify
touching.
whether it is oxygen knob or nitrous
Or
oxide
nitrous.
knob you are using. Okay, so that is not to control the hypoxia. It's to control your control over the knob. Okay, so by touching over a period of time, when you touch the knob itself, you should be able to say whether you are touching the oxygen knob or the nitrous oxide knob. Then there is a valve stop here. So you cannot move the valve beyond this point. So this is called the valve stop. This is a needle which fluids are open. This is the inlet from oxygen inlet from the cylinder. This is what is called the valve seat. And the gases flow through this. This is called the flow stop, where this float will not be able to move beyond this. This is the float or bobbin. This is the tapered flow tube. Then this is a float stop on the top also, so that it doesn't move out and go out. And this is the gas outlet going to the manifold. Okay, so these are all the parts that you have to remember. Now, continuous flow machines use variable bypass vapor pressure, which are mechanically or electronically controlled. Each is designed to calibrated for specific anesthetic vapor. Now, what are the safety features on or downstream of the back bar? You know, every anesthesia machine, whether it is an old anesthesia machine or the modern workstation, all of them have a back bar. Okay? So the back bars are usually fitted with the oxygen failure warning device and spring-loaded non-return valve, pressure relief valves, and emergency oxygen flush. All these things may be situated on the back bar. Also, the vaporizers are fitted onto the back bar. What are the functions of a modern anesthesia workstation? What functions they carry out? Safe provision, selection, delivery of anesthetic gases, okay, into the breathing circuit. Backup supply of gases in the event of failure of the pipeline. Respiratory support in the form of ventilators. Okay. Monitoring machines are also coming along with the newer workstations. Monitoring of patient physiological variables, automated archived record keeping. The more and more sophisticated machine you buy, they automatically do the recording also, which you were doing manually earlier. Integration of display and auditory signaling. And provision of appropriate connection to anesthesia gases scavenging system. And provision for medical vacuum or a suction, which is incorporated to the machine. Provision of supplemental oxygen via auxiliary flow meter. And work surface and storage facility for everyday items. And provision of mains electricity sockets for low consumption items, along with monitoring anesthesia and syringe pumps, etc. And also, they should have a battery backup of at least for 3 hours. Okay, so these are all the things which you have to mention if you are asked about functions of modern workstation. And what is the basic design of a delivery system, that is oxygen delivery system or the anesthetic gas delivery system in anesthesia machine? You will have a rigid metal frame on wheels which can be moved on all directions. What are those wheels called? Specific name for that? Which can rotate on all 360 degrees. Okay. Right, find out and tell me. Pressure regulators for reducing the high pressure. Then secondary regulators for damping surges. And pressure gauge to show the pipeline and cylinder pressure. These are all the basic things should be available in every anesthesia machine. So when you want to purchase a machine, you must see whether all these things are present. And the flow meters, which are used for proportioning and delivering the gases. System of attaching vaporizer to the anesthesia machine. Safety mechanism to warn the failure of oxygen supply. And safety mechanism for releasing high pressure buildup of gases. And system that bypasses the flow meter for the administration of high flow of pure oxygen. And inbuilt connection to circuit breathing system with facility to switch to a single outlet for delivering gases. For all these points that you have to remember for basic design. What is the most important goal before you start using your anesthesia machine every day? Or important checks that you must do rather than the word goal? What is the important thing that you must check whether it is available in the OT?
Ambu bag.
Manual resuscitation.
Fantastic.
Backup systems.
So it is the responsibility that the workstation or breathing circuit is a potential cause of difficulty with ventilation or oxygenation. Switching to a self-inflating bag is a appropriate is a very important thing, even in Miller's anesthesia. So ventilate and oxygenate first, troubleshoot later. That is the goal. And the most important part of the reuse anesthesia workstation checkout is the verifying the presence of the self-inflating resuscitation bag. This point you should never forget in the examination. This is the first answer you have to give. Now, can you trace the path of the gases and vapors from their source to the patient?
Pipeline to
Very good. Sources of gas supply can be central from water outlet cylinders to hung from yoke assembly. Very good. Then from there
the-
where do they?
Pressure regulator to the flow meter.
Very good. Pressures are reduced by pressure regulator before gases reaches the flow meters. Excellent.
meter.
Then
From there
from
it
the
passes
flow
through
meter,
vaporizer to the vapor. Okay.
they also go to the oxygen failure
Sustain
devices
device.
incorporated before the flow meters. Okay. And flow meters is the beginning of low pressure
Low
segment.
pressure segment.
And vaporizers fitted next to the flow meter downstream of flow. Okay. Finally, gases and vapors are delivered through common gas outlet at atmospheric pressure. So when the gases come out at the common gas outlet, some examiners may ask you what will be the pressure. It will be equal to atmospheric pressure. So from a very, very high pressure area, then there is an intermediate pressure, then there is a low pressure. And all these pressures at the earlier stages were higher than the atmospheric pressure. And that is why they are able to flow. And once they come up to the outlet, the common gas outlet, at that level they become atmospheric, equal to atmospheric pressure. Okay. So how are pressure systems in the anesthesia machine classified? Of course, this
Low,
is the same
high
answer.
pressure, intermediate pressure, and low pressure.
And what are all the various pressures? Also, you must know if it is a cylinder, it will be 220, 2200. If it is a nitrous oxide cylinder, 750. And it is reduced to 45 psi. Whereas if it is a pipeline, it will be straight away 55 to 60. Okay. What are the units and measurements of pressure and their correlation? This is a very, very important point every anesthetist should know, because the pressure is measured in various units. Can you just say what are all the units used for measuring or indicating the pressure?
Bar,
One bar
atmosphere.
is equal to 100
One
kPa.
at a time.
If
Commonly used nowadays is kilopascals. All the books start using kilopascals. Earlier it was millimeters of mercury, centimeters of water, bar, okay, pounds per square inch. All these things were the various measurements or units that were called. So PSI, PSIG, which means pressure pounds per square inch in gauge, PSA absolute, and PSA PSG plus local atmospheric pressure. But this is the correlation. 100 kilopascals is equal to 1000 millibar, 760 milliliters of mercury, which is equal to 1030 centimeters of water, which is equal to 14.7 psi, which is equal to 1 atmosphere. So you can 1, 2, 3, 4, 5, 6 units are there for measuring the pressure. So kilopascal, bar, millimeters of mercury, centimeters of water, pounds per square inch, and atmosphere. So you must know the correlation between all these things. And the common question the examiners are asking in the exam is, what is 1 kilopascal is equal to in millimeters of mercury? So from this equation, can you tell me how much 1 kilopascal will be equal in millimeters of mercury? 7.6 millimeters. So if you divide 760 by 100, it is 1 kilopascal, it is 7. So roughly you can remember 7.5 mm will be the equivalent of 1 kilopascal. Okay. So blood pressure monitoring sometimes is told in kilopascals nowadays. And so you must be able to convert it into millimeters of mercury for easy identification. What is the effect of altered barometric pressure on delivered concentration of volatile agents? Is there any alteration? These are the things. Because this is more with the vaporizer, so I will not go with that. What is an anesthesia machine? This one was the first made machine. So it's a device which delivers a precisely known but variable gas mixture, including anesthetizing and life-sustaining gases. Okay, that is the definition of an anesthesia machine. And the original Boyle machine was made by a firm called Coxeter. Okay, Coxeter's machine was the made, but Boyle is the name that has been carried out. So how anesthesia machines are classified based on the gas flow, and give examples. So intermittent gas flow or continuous gas flow. These are the two types of gas flows in the fan. The intermittent gas flow machines are Enternox apparatus and Matheson's apparatus, which are not used regularly for anesthesia, but the Enternox is used for what is the
Labor
purpose of
analgesia.
labor analgesia for inhalation labor, and Matheson's also is a similar machine. Whereas continuous gas flow machines are used in anesthesia. The examples are Boyle, for either Draeger, Datexometer, whatever you want to say nowadays. And what changes were incorporated in Boyle's machine over the period of time? This is a very favorite question of one of the examiners who has written an article on anesthesia machines in the Indian Journal of Anesthesia. So year-wise, they have given all the improvements or additions that have been made. So if you see that, this is like a history. So in 1917 was the first introduction of the Boyle by this man, Henry Edmund Gaskin Boyle, and it underwent modification between 2026 vaporizer bottles were added. In 1930, plunger device was added to the vaporizer bottle. 33 dry bobbin type of flow meter instead of watertight feed type. Earlier it was like this. And then 1937 rotameters replaced by dry bobbins of flow meter. And various safety devices have been introduced on and off in the modern anesthesia machine. So can you identify this? This is the Coxeter machine, which now Boyle marketed it or introduced this, so it is called the original Boyle's machine. Can you identify these things in the picture? Identify the person and the equipments.
Asking Boyle.
First person is it because just now I told you about this, so he is the person who introduced the machine, Henry Edmund Gaskin Boyle. And this is the first prototype which I showed in the earlier picture. And this is the modified version called the Boyle S. Okay. What are the components of various pressure systems? That is high pressure system, intermediate pressure system, low pressure system. They all have some have the components. So for want of time, I will go through that. Hanger yoke assembly, cylinder pressure indicator, Bowden gauge, pressure reducing valve. These three things belong to the high pressure system. And once the pressure is reduced from the pressure regulator or the pressure reducing valve, it comes to the intermediate pressure system where there is a pipeline inlet, pipeline pressure indicator, piping, gas power outlet, master switch, oxygen pressure failure device, oxygen flush valve, second stage reducing device, and flow control valves. All these things come to the intermediate. And the low pressure system starts from the flow meter, flow indicators, unidirectional check valve, and pressure relief valves, and vaporizing mounted devices, common fresh gas outlet. All these things come under the low pressure system. What are the parts of high pressure system? Where do they differ? Again, this is the various things. Parts of the hanger yoke assembly, which we saw from the beginning. You can say it can be called as body, then retaining screw, and then the nipple for gas entry into the machine, index pin, and then washer and filter. So these are all the parts of this hanger yoke assembly. What is shown here? Again, the same thing what you have seen, oxygen nitrous oxide cylinders with valve blocks. The
Valve
whole
blocks.
thing is called the valve block. Okay, all these things are called valve blocks. And what are the components of a gas cylinder? That is portable gas cylinders which you fix. Sometimes they ask you about the components. It can be the main part is the lower down. This whole thing is called the body. This is the shoulder.
Shoulder.
This is the neck or the port
Neck.
where the stem, everything is fixed in that. Okay. And what are the materials used in the making of cylinders? All these portable cylinders are the cylinders in the manifold. What is the material out of which they are made up?
Aluminum.
Neodymium.
molybdenum steel
Molybdenum.
and also aluminum. MRI compatible cylinders are made of aluminum,
Aluminum.
whereas the other cylinders are made up of what is called molybdenum steel,
Molybdenum steel.
chromium also. Okay. Pressure relieving devices are here. This is again the picture which I showed you earlier. This is where the conical depression is where the retaining screw will come and fit. So by tightening it, you will be pushing the cylinder more towards the pin index pins, and then it will prevent any leak occurring in that, and also will be able to hold that. And this pressure release device here, they will be asking about it. How
That's
does
your
it help in the
disc plug.
relief of pressure? It is made up of a substance called Woods alloy.
Fusible plug.
Fusible plug, or also called Woods alloy, which is made of bismuth, lead, tin, and cadmium. And it will melt when the temperature increases to 150 to 170 degrees Fahrenheit. And because of that, it will get blown out and all the gases will leak out without causing any explosion. Okay. So Woods alloy, where is it? If they ask you, the answer is it is in the pressure release in the valve block of the cylinder. Okay, that is a common question asked in the examination. So this is also called the flush type cylinder valve. Okay, because it flushes with the machine nicely, it is called the flush type cylinder valve. What is the pin index safety system? Already you have seen that. So to prevent interchange of gases, and these are all the various numbers which you have to remember. What is the pin index for air, carbon dioxide, the helium, oxygen? What are the different dimensions of the pin? Also they ask. They are 4 millimeter in diameter and 6 millimeter in length. And what is the pin index for Etanox?
7.
7, yes. And the length of the pin is 7 millimeter. It is a single pin. Okay. So, what is the color coding of different gas cylinders?
Black with white shoulder.
What is the purpose of color coding?
Safety mechanism.
Safety mechanism. You can identify it easily without reading through the label or the things imprinted on the neck. Can easily identify. Even uneducated people can be told, you bring the blue cylinder, you bring the black cylinder, you can say that. And so wrong mounting can be avoided. Okay. So these are all the color coding. Oxygen usually will be green or black with a white shoulder in our setup. And nitrous oxide is called French blue. So it is looking appearing blue, which is to be called French blue. And suction usually yellow, and carbon dioxide gray, and helium brown. So what are the functions of the check valve assembly? It prevents the gas from going in the reverse direction. Allows gas from cylinder to enter the machine without going back or going to the next outlet. And safety device in the yoke is the alloy crystal plug and copper fragile disc. These are the things which I told you earlier. This is the picture from the modern anesthesia machine. Okay, can you identify that? This is the Datex Omida estima machine with the back plate removed. So when you go back and tomorrow see in your theatre, your workstation, you won't find anything out like this. Everything will be sealed in a back plate. So unless you remove that, you can't see all these parts. Demonstrating cylinder yokes. That is a hanger yoke assembly will be there for primary regulators of oxygen, nitrous oxide, and air. Above all, there is an aluminum single block manifold carrying NIST and SPO outlet. And this is the manifold arrangement, what is called the Blease anesthesia machine. It's a coil nylon tubing, because this may not be asked in the examination. And again, this is a cylinder yoke with empty right hand. This is the empty right hand cylinder where there is no cylinder attached. This is the retaining screw, and this is the rectangular thing for holding the turning the screw. And this is the cut section, how these things are looking. Now, what is the filling ratio and why it is important? This is a question asked about the cylinders. What is the filling ratio and what is its importance? It is a
Usually, weight of the fluid filled in the cylinder to the weight of the water which is needed to fill the cylinder.
very good. It's a ratio. The filling density or percent ratio, weight of the cylinder, gas in the cylinder to the weight of water that the cylinder would hold at 60 degrees Fahrenheit. So it is only for liquid gases which are stored in liquid form. There is only the filling ratio or filling density is important. Why? Because they will evaporate and the pressure will increase at a higher ambient temperature area. Whereas in a colder climate, it may not evaporate that much and pressure will be low. So if you manufacture the cylinder in a colder climate and transport it to a higher ambient temperature area, there is a chance that the pressure inside the cylinder may build up enormously and the whole cylinder can explode. So you don't fill the cylinder with the liquid anesthetic agent to the full capacity. You do it only up to 75% or 68%, 70%, so that there is enough space for the gas to form even at a higher temperature, and it will not form any life-threatening explosion cannot happen. So that is the idea of filling ratio, because these gases are not in the gaseous form; they are in the liquid form, which becomes a vapor. Okay. So that is the reason why filling ratio is only applicable for nitrous oxide and carbon dioxide, which are liquid phase, which are in the liquid phase, which vaporize and become gas before delivery. Okay, so that is the point that you have to remember. What are the tests done to assess the integrity or the strength of the cylinder, and at what interval is another question. The tests done are called tensile test, flattening test, bend test, and impact test. And they are done at least 1 out of every 100 cylinders and every 4 years. So for every 4th year, one cylinder out of 100 cylinders will be tested of that, and it will be imprinted on the cylinder itself. The test carried out, date and which quarter of the year it is done. Now another question which you have all to be able to answer is, what is the critical temperature and critical pressure of a cylinder or a gas rather? What is the definition of critical temperature and critical pressure of a gas? So
Temperature
below which the
at and above which vapor of the substance cannot be liquefied.
cannot be
Okay?
liquefied.
No matter how much pressure is applied. Okay. And if the critical pressure of the substance is the pressure required to liquefy the gas at its critical temperature.
At its critical temperature.
Yes. What is medical air? This is a definition of, nowadays we are all using air in our anesthesia machines. What is the definition of a medical air? You cannot use any air that you are able to get. So the definition is, it has to be not have any detectable liquid hydrocarbons, and it should be less than 25 parts per million, because the air that you can generate from when you go to a petrol pump to fill up your tire, what you get is a very polluted air which you get from a machine that is producing that air, a compression pump. Whereas the medical air should be purified, and it should not have these hydrocarbons at more than this level, and particulate matter also more than one micron size should not be there, and low levels of nitric oxide also found in the ambient air may improve oxygenation in ventilated patients. Now, how to calculate the percentage of oxygen when you are using air? This is the formula. So for want of time, I will rush through this. So if you are using 2 liters of oxygen and 2 liters of air, You can calculate it will be roughly about 60.5% of oxygen that you'll be using. And this is another definition, adiabatic and Joule-Thomson effect. Can anyone define this? What is adiabatic effect and Joule-Thomson effect?
Cooling of the temperature while a gas released from the cylinder.
Very good. That is it adiabatic or Joule-Thomson?
Joule-Thomson.
Joule-Thomson. What about
Joule-Thomson.
what is adiabatic, diabatic or adiabatic? No heat is released. Okay? When a gas is subjected to sudden compression, the heat energy is produced rapidly, and the reverse occurs when there is a sudden expansion. There is no exchange of energy with the surrounding. This is what is called adiabatic change. Okay? So when you fill a cylinder with the gas under high pressure, there is a heat energy produced. Similarly, when you reverse this, that is when you release the gas and reduce the pressure, there is again a heat energy is produced, but there is no exchange with the surrounding atmosphere. With all the heat is conserved within the gas itself, and that is called adiabatic. Okay. In Joule-Thomson, the gas allowed to escape through the narrow opening. There is a sudden drop which will cool the air that is happening and surrounding the releasing area, and it will form droplets of water because the water vapor will condense, and you will find especially nitrous oxide cylinders may have this water vapor condensation, and even ice formation can happen. And that is called the Joule-Thomson effect, cooling of the air surrounding the area of release of gas under high pressure, which causes cooling in the decrease in the temperature. What is shown here, especially these things which are fitted into the hanger yoke assembly with that retaining screw and the toggle lever. Is it a part of the cylinder or something else? They are called blank plugs, okay, dummy or the blanking plug. So whenever you are not fitting any cylinder into the hanger yoke assembly, it has to be kept closed by this blank plug. Otherwise, what will happen? Some dust will go and accumulate in the entry port of the gas, and that may cause maybe the cause for explosion or fires hazard. So it is always a healthy habit to keep it closed, that entry point to be kept close with this bulky blanking plug or the dummy plug when cylinders are not used. And you find the two unusual gas hanger yoke assemblies here.
Cyclopropane and carbon dioxide.
Cyclopropane and carbon dioxide. Why cyclopropane was used those days? I mean, who used popularized cyclopropane? And this is the color of the cylinder also. The cylinder color used to be orange like this.
Orange.
Not available nowadays. Cyclopropane was introduced by person who introduced the to and fro canister. This is the clue. What is his name? The carbon dioxide absorbing canister was introduced by this man. Cyclopropane was introduced by this man, and he also shares the credit for introducing pipentone as an induction agent along with Lundy. It's called Ralph Waters. Okay, Ralph Waters of USA.
Waters.
Because he is the person who popularized both cyclopropane and to and fro canister. Okay. What are the pin index system incorporated for? All of you know that it's because to prevent the wrong cylinder being mounted. And still, can you fix a wrong cylinder in spite of having a pin index? What are the methods by which you can still fix a wrong cylinder? By using two washers at the port. And the second is, if the pins are broken, then you can still fix that. Or the holes in the cylinder valve are too deep. These are the three reasons where still a wrong cylinder can be fixed to the yoke. Okay. So what is missing in this picture?
Nipple.
This is not a nipple. This is the entry port for exit port
What?
from
Bodox
this.
seal.
Huh?
Washer is missing.
Bodox seal is
Washer.
missing. Excellent.
Washer. Got it.
Bodox. Sorry. What's shown here?
Pressure gauge.
Oxygen pressure gauge. It is written here.
Pressure gauge.
Oxygen. What are the safety
Oxygen
features
pressure.
in the pressure gauge? Another common question in the exam. This is the Bowden certificate here. Working principle of pressure gauge. What are the safety features of the pressure gauge? The answer is it is usually color coded. Name and symbol of the gas is written. Bowden tube rupture, gas vented only from the back side of the cylinder. It will not come in the front. And gauges are angled and placed in such a way that it can be easily read. And there is an instruction as use no oil. You can find there is a warning, use no oil to open the valve slowly or written in some of the gauges. Okay. So open the cylinder slowly. It's also written here. Use no oil. The name of the gas is written, and the marking to show that the gas is reducing. The volume of the gas is reducing by the reducing pressure. It gives you a warning: refill or replace. So all these things are safety features of the pressure gauge. What is this? Have you ever played with this toy?
Yes.
What is it? Anybody knows the name for this? It is called blow-out noise maker, also called party horn. Okay, so by blowing this, all the children would have seen it will roll out into a long strip and it will make a noise also. So the same principle is only used in this Bowden gauge. So when you apply a pressure here, this tube unwinds. The circulated, the rotated circle, the tube unwinds. The same principle is used here, and that is why I have shown this here. And can you identify this person? So if you connect my previous slide with this, you can identify this person. He is called Eugene Bowden. Okay, he only introduced the Bowden pressure gauge. Okay, so how does the nitrous oxide gauge differ from oxygen pressure gauge? Will it read the? Will it be able to reflect the content by looking at the pressure gauge in nitrous oxide?
No, only the vaporized content.
Right. So we show the same pressure till the last drop of nitrous oxide level. Because I told you the nitrous oxide is stored in the liquid form. So till the last drop of that liquid vaporizes and becomes a gas, it will show the same reading. And then suddenly it will go to zero. Okay. So that is the reason why that's the main difference. Whereas in the oxygen, you can, you start with a full cylinder, if the pressure gauge reaches to 50, comes to half the pressure level, it can say still 50% of the gas is left inside. But in nitrous oxide, you can never say that. Okay. What are the features of pipeline inlet connections? The entry point gases for nitrous oxide and oxygen air are given at the back, and they are connected with what is called diameter index safety system. And the features of pipeline pressure indicators are their pressure, working pressure is 50 to 55, and the cylinder is open by this pipeline supply phase. There will be no change in the indicator pressure till the cylinder is nearly empty. So if gas pressure coming from the cylinder via a pressure regulator exceeds pipeline pressure and the cylinder valve is open, gas will be drawn from only the cylinder. So cylinder should always be kept closed when the pipeline supply is in use. So this is one question they ask you: why should you keep the cylinders closed even when they are mounted or fitted? This is the reason. So pipeline machines will preferably take the gas from the cylinder rather than the pipeline. So that is the reason why you should always keep them closed. Why pressure regulators are needed in the anesthesia machine? It's because you maintain a constant flow and also reduce the high variable pressures. What is the physical principle used is there. This is the principle that is used. Why pressure regulators are also called preset regulator because they reduce it to a preset level of 14 to 15 psi. Why cylinders fitted to machines we kept close? Of course, I have told you the answer earlier itself. Now, in this again, this is a picture of. Can you identify what is this picture of? The older machine. Any of you have had a chance to remove the top covering part debris from the older anesthesia machine and look into the components lower down? This is the pressure regulator. Okay, so this is the pressure regulator in the older machine. This is the safety release valve. These are small vents for leaking out excessive gas in case the diaphragm is damaged, and this is the tubing going to the flow meter. There are different types of pressure regulators, which we will not go into detail. Oxygen flush. So questions will be asked about the oxygen flush valve. So how many liters of oxygen will be delivered if you activate the oxygen flush valve?
30 to 60 liters. Sir.
Very good. And what pressure? 35 to 75 liters per minute can be given.
70.
And maybe the cause for barotrauma because it comes at a higher pressure compared to the flow meter. And what modifications are made in the oxygen flush in the workstation?
There are two oxygen flush in.
See, this is one older type. This is the newer type. You can see this. This is again the oxygen flush now in the older workstation. This is the newer workstation. What is the difference you find in this? You find,
It came out from.
So this can be accidentally activated even if by your elbow or anything. But here, because there is a protective bar, just like what I showed in the earlier knob for flow meter, there is a protective bar which will not allow you to touch it. Okay, and it will slide back to its original position. Okay, so the workstation standard requires oxygen flush valve to be self-closing and designed to minimize unintentional operation. And modern design for oxygen flush is shown here. Note that the button is recessed. That is, it is at the interior level, not at the surface like this. So accidental activation will not be happening. What is the mechanism of action of oxygen flush? How it is able to deliver at a higher level is, this is a flush button. When you press it, there is a pin, there is a ball valve. So 40 to 50 psi, the higher pressure gas will come out and it will come out to the machine outlet. So the pressure coming out is at a higher pressure and the volume that is coming out is 35 to 75 liters. So there are every chance that it may produce barotrauma if used without discretion in all patients. Okay. What is shown here? What are the mass parts? Of course, again, those of you who had not had a chance to see the older machine, this is the components that are seen after removing the machine will be like this. This plate you can remove. What I have marked here with the black line here, the green plate, it is removable. So once you remove this, you will see seeing all these parts. So these are all the parts that can be sometimes asked to be identified. So these are all the various things. This is the nitrous oxide pressure gauge, this is the nitrous oxide pressure regulator separately, and this is for oxygen, this is the oxygen pressure regulator, this is the low flow alarm system, ventilator outlet, closed circuit, common gas outlet, oxygen flush is here in this machine. So these are all the parts which you can see underneath this top covering of this table. Okay. Then how to calculate the amount of gas in the nitrous oxide cylinder? This is a question that may involve what is called Avogadro's hypothesis. What is Avogadro's hypothesis? 1 gram of molecular weight, that is mole of a substance, will occupy 22.4 liters at standard temperature and pressure. So using this Avogadro's hypothesis only, you can calculate the volume of all the gases that is available. So this is the calculation. Weight of the cylinder with the gas, nitrous oxide is 1.6. Tar weight, that is empty weight, is 4.5. So the weight of nitrous oxide is 1.14 kg. And the molecular weight of that is 44 grams, which will occupy 22.4 liters. So out of 1.1 kg, this is it. So 560 liters will be the amount of nitrous oxide gas will be there. And if you use it at 2 liters per minute level, it will come for 280 minutes, which will be roughly 4.6 hours. So that's how this calculation also sometimes can be asked. Whereas for oxygen, this is not the thing, because it applies what is called Boyle's law. So these are all basic questions which examiners repeatedly ask you. So for oxygen, the calculation is done using Boyle's law. For nitrous oxide content, you have to use Avogadro's hypothesis. And how can you calculate the duration of supply from a E-type cylinder? By using this equation, hours of supply is equal to pressure inside the cylinder divided by 200 by liters of flow per minute. So the cylinder pressure of 10,000 psi, flow rate 2 liters per minute, it will last for 2.5 hours. And what is shown here, the modern anesthesia machine. All of you would have been using this every day. This is the pointer here, and I have highlighted that here. And it is written here system power. So that is the clue. So what is this?
Electronic switch
switch, sir.
between the on and power.
It's called the master switch to activate the working state.
Master.
Okay. How does the gas flow increase in the flow meter? It is because of the tapering gravity in the specific of another opening. What factors govern the flow of gases in flow meter is another common question. When will be viscosity important? When will be density important? All that is available in the book. So low flow, smaller annular space, flow is laminar, it is viscosity. When the flow becomes
High flow.
turbulent, density becomes the important factor. And this is the, again, a picture earlier I showed you, this is the electronic flow meter. Advantage of that, the information can be sent to data management directly and it can be recorded. Disadvantage, it will not work if the electricity supply is not there. So you must always have a good working battery in the machine to continuous display and working of this machine. So here you are seeing, what are you seeing here? Again, flow meters, twin flow meter and a single flow meter. Okay. So constant pressure throw. This is a tube design and the dual taper. So you can see this is a single tube, but the tapering is different here. Up to this 1 liter, it is in a smaller diameter. After that, it becomes wider. Okay. Whereas in the older, it will be uniformly like a almost like a V. Whereas here, it up to particular level, it is almost parallel. Then suddenly it becomes widened. Okay, so this is called the dual taper design. These are used. What is the material out of which this flow meter tube used can be asked? That is a borosilicate glass pyrex is the answer for that. And what is the purpose of single or double taper tube? Already you answered for low flow, the high flow. I think we stop here, continue in the next class, because it's already 3 hours now.
Okay.
Okay. It's a huge topic. I don't think we'll be doing justice by rushing through like this. So time permits, we have it completed before we all go for the exams. Okay.
Okay.
Any questions?
Thank you very much, sir.
Doubt?
Any
Huh?
questions? Thank you very much, sir. Students want one more session on Friday, sir. Can you do them, sir?
This Friday.
Yes, sir. ASCII, only ASCII.
Ask you. Yeah. Okay.
Only ASCII, sir.
Right. Okay. I will continue this and then try to finish up.
Yes, sir.
If possible, I will include Apparatus also in that, because Apparatus is a
Okay.
separate one. So we'll complete the balance of machine and then go for Apparatus. Okay.
Yes, sir. Thank you so much, sir.
Okay.
Thank you, sir.
Good night.
Thank you.
Thank you, sir. Can we sign up today's meeting, sir?
Thank you, sir.
Thank you. Thank you so much.
Thank you.